Welcome everybody to the presentation of the EBF rooftop greenhouse of the GROOF project. First off, I would like to present myself and EBF quickly before jumping into the discussion. My name is David Volk. I'm a physicist working for EBF as an energy consultant expert and greenhouse developer. As part of the GROOF project, I work as the leader of the energy team and I have overseen the rooftop greenhouse construction. EBF is a small company in the energy consultancy business for more than 25 years now and works on implementing new and innovative food and energy solutions internationally for a sustainable and secure future. Now, onto the presentation of the rooftop greenhouse. We started with the preparation of the support building. As you can see, the former packaging hall in the nursery was run down and barely functioning. We started with removing the rooftop and leveled out the brickwork. To achieve maximum stability, a reinforced concrete ring beam was installed on top of the walls, which gave us a plain anchor point for the greenhouse platform and finally the greenhouse itself. In this overview, it can be seen how after finishing with the concrete, a nice and clean basis was established for further construction. After finishing the concrete foundation, the large wooden beams were put in place as the basis for the greenhouse platform. Parts of the old roof could be reused as traversing beams and posts. The gaps were filled up with hempcrete to guarantee full insulation of the support building. The last two layers of the platform consist of OSB panels and bituminous sheeting, creating a nice and dry ground for the greenhouse. After the installation of the platform and the railings, everything was set for the greenhouse structure itself. First, the main posts were fixed through the platform into the large wooden beams. By the way, drilling through the ceiling layer is not a problem, since the inside of the greenhouse is dry at all times. Not so much during installation in a typical and beautiful German summer. Despite all heavy parts involved, no heavy machinery was necessary. The whole structure of the Sunlight greenhouse has been developed by EBF in the last 5 years. All details can be found in a 3D model which represents the actual greenhouse and is used to test all necessary adaptations first and are then directly forwarded to the workers on site for quick implementation. With the installation of the aluminum arc profiles, the structure was completed and the hull construction could be started. The next step in the process was about the construction of the hempcrete side walls. First, hemp earths, lime and porcelains are mixed with a bit of water. After a few minutes of mixing, a homogeneous mass is achieved and the hempcrete can be used for construction. Around the greenhouse, the basis of the hempcrete wall is a layer of planks which is fixed to the steel structure. Vertical planks are added for the formwork planks and of course for stability of the wall itself. The hempcrete is stuffed and compacted so that the material reaches uniform density. Hempcrete has the nice property in that it can be stuffed into narrow corners or various shapes and therefore is very flexible in its application. Next to the nice insulation properties, hempcrete also joins into the humidity exchange with the greenhouse interior, regulating the indoor climate. After one day, the hempcrete is dried enough to support itself. The formwork planks are removed and will be fixed to another part which is not completed yet. Slowly but persistent, the walls grow around the greenhouse. Hempcrete is the first material with real practicability in the greenhouse construction business, which can be composted completely. All alternatives like sandwich panels, even with natural materials, are still using composite materials, which generate waste. After the end of its lifetime, hempcrete can be reintroduced into the natural material flow and therefore reducing the environmental impact of the greenhouse tremendously. Parts of the roof are being stuffed with hemp straw, building up a nice and natural lightweight insulation. The last step of the construction is the installation of the ETFE cover. ETFE is a fluorine-based polymer with really good transmissive properties and a long lifetime, making it exceptionally well adapted to the greenhouse sector. For the sunlight greenhouse, a double-layer film is installed. Here, the installation of the first layer can be seen. The inner layer is a diffuse film with 60 micrometers thickness. The diffuse grade of the film helps with scattering and creating an equal light distribution within the whole greenhouse. So, even in summer, when the sun is too high to reach the backside of the greenhouse, indirect light will still be spread, creating a low-intense light environment for leafy greens or comparable. The second layer is a clear 100 micrometer film, which is mainly there for stability and creating an insulation cushion. All in all, the ETFE generates a highly transparent cover while still achieving good insulation properties. Additionally, ETFE is UV transparent, resulting in not only a long lifetime and slow degradation of the material itself, but also generates a better growing environment for plants. The sunlight greenhouse is a lean-to style greenhouse. The sidewalls and part of the roof are insulated, so that the heat loss is diminished at night times and in winter. Later, a thermal blanket will be added, which can be rolled down over the film, which adds even more insulation. All measures lead to a low energy demand greenhouse, which can, with the proper lighting added, even be used all year, or alternatively, the greenhouse can be used completely passive. Then of course not all year round. In the case of the rooftop greenhouse, surplus heat is transferred to the support building, increasing efficiency and reducing heat demand in the support building. For the growing system, we are using the Dutch buckets. The substrate is a mixture of soil and palaterra. Palaterra is a nutrient-rich charcoal fertilizer which gets mixed into the soil and releases the stored minerals over the course of a few years. That means we can use the same growing soil for a longer period and don't have to change the substrate every year. This helps a lot with reducing back pain getting the buckets onto the roof. The origin of this growing technique dates back to the Amazonian Indians, who could restore washed-out rainforest soil and create ideal growing conditions for their crops. Now it is being adapted for a substrate-based hydroponic system. For better light and temperature control in summer, the PV system is used to reduce the sun intensity by 60% and produces electricity. Due to the diffuse inner film of the greenhouse, there's still enough and nicely equal distributed light for plant growth available. When there's not enough light, the PV panels are rotated out of the sun to give the plants what they need. The main goal of the project is to examine the CO2 reductions due to the synergies of the support building and the rooftop greenhouse. With the project ending soon, first results are being calculated at the moment and will be released in the next weeks. Thank you for listening to this short report about the EBF pilot rooftop greenhouse in Germany. Have a nice day and see you soon!